It happened in the dead of Martian night. October 28th, 2025. One moment, the interstellar visitor 3I/Atlas was there, tracked by three orbital sentinels circling the red planet, monitored frame by frame, second by second. The next moment? Gone. Not gradually, not predictably, just gone. And here's what makes this absolutely wild. NASA went silent. Completely silent. No press briefing. No data dump. No reassuring tweet saying everything's fine, folks. Nothing. In an age where space agencies live stream rover landings and post daily updates about Martian weather, this radio silence felt deafening, almost deliberate. So what really happened up there? Did Atlas simply drift behind Mars as predicted? Or did something else occur? Something that doesn't fit neatly into our models of celestial mechanics? Let me take you through what we know, what we don't know, and why the silence might be the most important part of this story. First, let's establish the facts. 3I/Atlas is humanity's third confirmed interstellar object. It came from beyond our solar system, traveling at speeds that clearly mark it as a visitor from the stars, not a local resident. When it approached Mars in late October, it presented a once-in-a-lifetime opportunity. Earth was blind. The sun's position made observation impossible from our planet. But Mars? Mars had the perfect vantage point. Three spacecraft were positioned to capture this cosmic encounter. NASA's Mars Reconnaissance Orbiter with its high-resolution imaging system. The European Space Agency's Trace Gas Orbiter with its sensitive spectrometers. And Mars Express, the veteran observer that's been circling the red planet for over 2 decades. The plan was elegant. As Atlas passed through Mars's orbital neighborhood, these three robotic eyes would track it continuously, gathering unprecedented data about an interstellar visitor at close range. The observing window was narrow, just 72 hours of optimal positioning. But it was enough, or it should have been. Mission Control uploaded the commands weeks in advance. The orbital mechanics were calculated to the millisecond. Every team knew their role. And then Atlas entered the observation zone. For the first 18 hours, everything went according to plan. The orbiters transmitted preliminary telemetry confirming target acquisition. The spacecraft were pointed correctly. The cameras were firing on schedule. And then, the updates stopped. Not the telemetry. The spacecraft were still healthy, still transmitting their housekeeping data. But the science data? The actual images and spectra of Atlas? Delayed. Indefinitely. Now, here's where it gets interesting. In the modern era of space exploration, data flows fast. Really fast. When Perseverance landed on Mars, we had images within minutes. When James Webb captured its first deep field, the world saw it within hours. But with Atlas, days turned into a week turned into 2. The official explanation from NASA was technical and measured. Data validation in progress. Preliminary processing shows complexities requiring additional analysis before public release. Sounds reasonable, right? Except here's the problem. Other missions don't work this way. Browse images, low-resolution previews, typically appear almost immediately. They're designed specifically to give the public and the scientific community a quick look while the full analysis continues behind the scenes. But with Atlas, even the browse images were withheld. Why? Some said it was bureaucratic caution. The data was unexpected, and NASA wanted to be absolutely certain before making any claims. Fair enough, science demands rigor. Others suggested technical difficulties. Maybe the images were corrupted. Maybe the pointing was off. Maybe Atlas was simply too faint to capture clearly. But then a third explanation started circulating in the forums and Discord channels where space enthusiasts gather. An explanation that's harder to dismiss. What if the data showed something NASA wasn't prepared to explain? Let me be clear, I'm not talking about little green men or flying saucers. I'm talking about something potentially more profound and more scientifically challenging. What if Atlas didn't behave the way an interstellar comet should behave? Think about what we already knew before it vanished. The spectral data was bizarre. Carbon dioxide-rich atmosphere without the expected water vapor. Metallic emission lines in ratios never seen before. a sunward jet that defied conventional physics. And that green flash, that mysterious, impossible green flash. Now, imagine the Mars orbiters captured something even stranger. A trajectory change that can't be explained by outgassing. A structural geometry that looks too regular, too symmetric. Or, and this is the wildest possibility, evidence of controlled maneuvering. If any of those scenarios were true, NASA would face an impossible dilemma. Release the data immediately and trigger global speculation before understanding it, or hold the data, verify every pixel, rule out every alternative explanation, and only then go public? The second option protects scientific integrity, but it also looks exactly like a cover-up. Here's what we know actually happened during those silent weeks. Behind the scenes, imaging teams were engaged in what one insider described as forensic-level analysis. Every frame was being scrutinized not just for what it showed, but for what could cause it to show that. Cosmic ray hits? Hot pixels? Electronic artifacts? Compression glitches? Each had to be identified and excluded. But there was another layer of complexity: alignment. When you're trying to detect an incredibly faint object moving incredibly fast, image stacking is essential. You take dozens or hundreds of frames and align them perfectly, then combine them to boost the signal above the noise. But here's the catch. If you misalign those images by even a fraction of a pixel, you can create false signals. Phantom streaks that look exactly like what you're searching for, but don't actually exist. So the teams had to verify alignment using star positions, then re-verify using a different method, then verify again using independent software. It's painstaking, it's time-consuming, and it's absolutely necessary. Because the worst thing that could happen, worse than finding nothing, worse than missing the object entirely, would be to announce a discovery that turns out to be an artifact. That kind of mistake doesn't just embarrass the team. It damages public trust in space science for years. So they checked, and rechecked, and checked again. But here's the question that kept gnawing at me as I followed this story. If the data showed nothing unusual, just a comet passing by as expected, wouldn't that be easy to confirm? Wouldn't browse images have appeared quickly, showing, yep, we saw it, looks like a comet, full analysis coming soon? The extended silence suggested something else. It suggested ambiguity, complexity, data that didn't fit cleanly into expected categories. While NASA remained silent, the internet did what the internet does best. It speculated wildly. Theories range from the mundane to the extraordinary. Theory 1, Atlas fragmented. Some suggested the object broke apart during its close approach to Mars, creating a debris field that was difficult to image and analyze. Fragmentation would explain erratic brightness, unusual spectral signatures, and the need for extensive data processing. Possible? Absolutely. Interstellar objects experience enormous stress from solar heating and gravitational forces. Theory 2. The data was too faint. Maybe Atlas was simply dimmer than predicted. Maybe the exposure times were insufficient. Maybe the spacecraft pointed slightly off target and only caught the object in peripheral pixels. This would explain the delay. It takes time to extract signal from extremely noisy data. But it doesn't explain the complete absence of preliminary updates. Theory 3. The data contradicted expectations. This is where things get speculative but fascinating. What if Atlas's behavior during the close approach violated our models so dramatically that NASA needed time to understand it before going public? Not because they're hiding aliens, but because announcing we observed something we can't explain without a plan for investigation would create chaos. Theory 4. There were multiple objects. Remember those whispers from amateur analysts who claimed to see companion objects in the Perseverance data? What if the Mars orbiters confirmed it? What if Atlas isn't alone? An interstellar cluster would be scientifically revolutionary, but also deeply puzzling. It would demand explanation, and NASA wouldn't want to announce it until they had some idea what they were looking at. And then there was the theory nobody wanted to say out loud, but everyone was thinking. Theory 5. Atlas maneuvered. A trajectory change inconsistent with natural forces would be, well, It would be the most important scientific discovery in human history. It would also require extraordinary evidence, the kind of evidence that demands months of verification, not days. 3 weeks after Atlas vanished from view, something finally happened. Not a press conference, not a data release, but a leak. Someone, somewhere within the imaging teams, posted a single sentence on a closed forum used by planetary scientists. The albedo variations are not random. Albedo means reflectivity, how much light an object reflects. For a natural comet, you'd expect random variations based on surface composition, dust coverage, and rotation. But not random implied pattern. Structure, possibly geometry. The post was deleted within minutes. The user account suspended. But screenshots had already circulated. Speculation exploded. Was Atlas's surface artificially structured? Were there regular features that suggested construction rather than natural formation? Or was this simply a scientist noting that the object had distinct regions of ice versus rock? Something perfectly natural but interesting to study? Without the actual images, there was no way to know. But the leak did one thing. It confirmed that data existed. Real data. Data that showed something worth discussing, even if that discussion was happening behind closed doors. Finally, on November 18th, NASA released a statement. Not the full data set, not the images, just a statement. Preliminary analysis of Mars orbital data confirms detection of 3I/Atlas during its October flyby. Object trajectory matches gravitational predictions within expected tolerances. Spectral analysis ongoing. Full dataset release pending peer review process. Estimated release, February 2026. February. For months away. The statement raised more questions than it answered. If the trajectory matched predictions within expected tolerances, why the delay? That should have been the easiest thing to confirm. And spectral analysis ongoing. What did that mean? That the spectra were complicated? Unexpected? Inconsistent with cometary models? Most puzzling, pending peer review process. NASA doesn't typically wait for peer review to release raw data. The data goes public, and then scientists write papers analyzing it. That's how open science works. Holding the data until after peer review suggested they were preparing a paper, a significant paper, before going public, which meant they found something. Something important enough to warrant formal publication before public disclosure. So where does that leave us? Atlas has now passed Mars and is heading back toward the outer solar system. It won't be observable again from Earth until December, when it emerges from behind the sun. By then, we'll have two chances to understand what happened. The Mars orbital data that NASA is still processing and new observations from Earth-based telescopes. But here's what bothers me about this entire episode. In an era of open data and citizen science, the extended silence around Atlas felt like a step backward. It reminded people of an older model of science, one where discoveries were hoarded, controlled, and released only when institutions were ready. I don't think NASA is hiding aliens. I really don't. But I do think they found something that didn't fit their models. Something complex enough, strange enough, or controversial enough that they felt they needed absolute certainty before going public. And maybe that's the right call. Maybe scientific caution is more important than satisfying public curiosity. But it creates a vacuum. And nature and the internet abhors a vacuum. So speculation fills the void. Conspiracy theories multiply, and trust in institutions erodes. Let me offer a different interpretation of the silence. Not a cover-up, but a genuine scientific dilemma. Imagine you're the lead scientist on the imaging team. You've worked for 20 years to get a spacecraft to Mars. You spent months planning this observation campaign, and then the data comes back showing something you've never seen before. Something that doesn't match any comet you've studied. Something that will make headlines around the world. What do? You can't ignore it. But you can't announce it without being absolutely certain. Because if you're wrong, if this turns out to be an artifact, a misinterpretation, a mistake, your career is over. The mission is discredited. Public trust in space science takes a hit. So you check and recheck. You bring in experts from other institutions. You run simulations. You test alternative explanations. And while you're doing all that work, rigorous, necessary scientific work, the world is screaming, "Where's the data?" From the inside, you're being careful. From the outside, you're being secretive. That tension is built into modern science. We want discoveries fast, but we also want them right. And sometimes those two things are incompatible. Here's what I think really happened. I think Atlas showed behavior that's at the edge of our current models. Not necessarily artificial, but genuinely anomalous. Maybe its outgassing pattern was more complex than predicted. Maybe its rotation was unexpected. Maybe its spectral signature revealed chemistry we haven't seen before in interstellar objects. Any of those findings would be scientifically significant. They'd warrant careful analysis, detailed modeling, and peer review before publication. But they're also ambiguous. They could be explained naturally. We just haven't figured out how yet. And that ambiguity is what caused the silence. NASA didn't want to announce we found something weird without offering an explanation. Because weird plus interstellar object equals alien probe in the public imagination, regardless of what scientists actually say. So they're taking their time, building their case, preparing their papers. And when they finally release the data, they'll have a narrative ready, a scientific framework that explains what they saw in terms of natural processes. Maybe that's the right approach. Maybe it protects both science and public understanding, but also means we wait and wonder and speculate. So, is NASA hiding something? Yes. They're hiding data that hasn't been fully analyzed yet. Is it nefarious? No. It's cautious. Maybe too cautious, but not nefarious. Is there something extraordinary about Atlas? Almost certainly. You don't delay data release for 4 months if the object is completely ordinary. Will we ever know the full story? That depends on whether the February release actually happens, and whether the data comes with enough context to let independent researchers verify the findings. Until then, we're left with questions. Why did Atlas vanish so completely from the public eye after its Mars encounter? What did those orbiters actually see during those 72 hours? And what's in that data that requires 4 months of analysis before release? In December, when Atlas reemerges from behind the sun, we'll get new observations, new data, new chances to understand this mysterious visitor. And maybe, just maybe, NASA will have released the Mars orbital data by then, giving us the full picture of what happened during those silent weeks in October. But until that day comes, Atlas remains what it's always been, an enigma, a visitor from the stars that refuses to behave the way our models predict, an object that raises more questions than it answers. And perhaps that's exactly what makes it so fascinating. So what do you think? Is the silence justified scientific caution? Or is there something more going on behind those institutional walls? Drop your thoughts in the comments. And if you want to follow this story as it develops, because trust me, this isn't over, hit that subscribe button and turn on notifications. Because when that data finally drops in February, you're going to want to be here for it.